Hello, this is our IE441 capstone project. We worked with John Deere Seeding Group out of Moline, Illinois. To introduce our team, we have Lucas Baker, Jacob Marks, and Ryan Smit. For our project, Deere wanted us to replace 3 existing machine centers with 2 new machine centers. These 3 machine centers consisted of 1 twin bore machine center that had no backup manufacturing process and 2 mooring machine centers that were identical. They were current and outdated machines. They are difficult to maintain and costly due to machines being shut down. There is an opportunity for better layout with the new machines, and this can cause for less shutdown time. Some objectives Deere wanted us to have for this project was to decrease the machining center and related operations work travel distance by 10% by identifying a new layout, create a more reliable and cost-efficient process, and help Deere better understand the material handling process.
All right, so before we're able to recommend new layouts for the future state, we fully needed to understand the current state. So we used a material flow analysis tool called Flow Planner, where we inputted data that Deere gave us, and there we were able to output a material flow process map that visualizes and quantifies the material flow throughout the facility. It also outputs a total time, distances, frequencies, and costs that are seen throughout the facility. So like Ryan said before, the twin bore does not have a backup plan. And so when there's any maintenance or any fixes that need to be done on this machine, there's essentially a halt in production. So this causes about $500,000 per year of downtime. And here is our current state layout. One thing to note is that this big yellow line that is present in this map, that's all the parts that are being brought from the west dock all the way to the machines. So this is a kind of some waste that we realized throughout this whole process, and so we looked at trying to reduce that. And this is the outputted data of the current state. And as you can see, there's about 4 million total feet that was traveled throughout the facility, and also about $13,000 spent per year on all these processes.
Moving on to the future state layout. Looking at the future state, we looked at multiple different layouts for our future state recommendation. We came up with this layout here, which implements 1 mooring in the current twin bore location, which is where on that left picture where the blue and green line meet. We placed 1 mooring machine there for this recommendation, and the other mooring machine where those 2 yellow lines meet. This recommendation, we also moved the shipping docks from the far west shipping dock all the way over to the east shipping dock. That one of the big advantages of this layout was also that it tightened up that workflow for where all those parts are moving to the east weld line, and also created that redundancy in the twin bore operations. Overall, this layout reduced the travel distance by 74% and reduced the cost by 50% compared to the current state. Over 5 years, one of the big gains was that 1,200 square feet in space freed up. That was due to the decreasing from 3 machines to 2 machines. Another big gain is the assumed 80% reliability gain from the twin bore operations. That is because the twin bore has that redundancy allowed with moving to a mooring process rather than the twin bore process. And then we also have a gain of $33,000 from decreased part movements over 5 years. Thank you, everybody, for listening.